So the patient's temp is going down still after 4 hours, which is good news for them because they're going to feel better the less of a fever they have. The next part is plugging into the second derivative, which can be a bit tricky to interpret. So we'll plug it in, and then I'll show you a general interpretation, and we'll apply it to this one. So we're going to do t double prime of 4, which means we first need to find t double prime of t. So I'm going to look at this simplified version of the first derivative here and take a derivative of that. So I'm going to bring down the power on this one. It's going to be negative 0.45 times negative 1/2. And then t, I'm going to have to do some side work. Negative 1/2 minus 1 is minus 2/2. So I'm going to get negative 3/2. Which we could combine those constants out front. We could grab our calculator and see negative 0.45 times a negative 1/2, and that gives us 0.225. It's going to be positive because we multiply two negatives together, t to the negative 3/2. So we're not just asked to find the derivative and then stop. We want to plug into it, so we want to do 0.225 times 4 to the negative 3/2 to see what we get. So we are going to plug in 4 of it to this t double prime of 4 into what we found, and I'm getting 0.028125. And this is going to be in degrees Fahrenheit per hour each hour. We could write per hour squared and that would still be correct, but for me it's a little bit harder to interpret unless I think about it as per hour each hour. So we want to interpret what this means. We can do it right under there, but off to the side over here, let's talk about interpreting the first and second derivative in general. So talking about two derivatives at once, because you can't describe the second derivative without also describing what's happening in the first derivative. So a kind of a random example of this is if we said and I'm just going to write something. Could be temperature, could be rain, could be anything that's changing. So the something is dropping increasingly rapidly. So when you talk about a second derivative, you have to talk about the first derivative first. So on this, when I say something is dropping increasingly rapidly, when we talk about the second derivative, we need to talk about the first derivative. So dropping, that tells me f prime is less than 0. And then how much it's dropping by is the second derivative. So that tells me the second derivative, it's dropping increasingly rapidly. So that would be the second derivative. We want to be dropping and we want to be speeding up. Increasingly rapidly means speeding up. What did we say about speeding up? Do the first and second derivative have the same sign or different sign? So if we want it to be speeding up, the second derivative has to have the same sign. So that first piece of information, dropping, tells me what the first derivative is doing. It's falling, so it must be a negative first derivative. And if it's increasingly happening, if it's going faster and faster, that means the second derivative also must be negative. So it gets kind of confusing. So I wanted to give you a couple examples of this. And we're going to do this in this problem and in the next problem. We're going to interpret the first and second derivative. But just kind of a side note, we want to think back to what we originally learned. In order for it to be increasingly rapid, they would have to have the same sign. If it said decreasingly slow or something like that, that means it was slowing down So they must have had different signs. But if it's speeding up, they have the same sign, even if the wording kind of sounds weird because it's dropping. And it says increasingly, so that might make you think positive, but that means they have the same sign. Just a lot to digest. So let's think about that when we interpret this one. So we have a negative first derivative and a positive second derivative. So is the patient's temperature speeding up or slowing down? What do you think is happening with this medicine? It's been 4 hours. So the temp is still decreasing because we have a negative first derivative here. So the medicine's still kind of working, but is it working faster and faster or slower and slower? Well, because the first derivative is negative and the second derivative is positive, yeah, it's working, but it's working decreasingly as slow. They must have opposite signs, because the medicine isn't just randomly having a big boost where it starts working even better after 4 hours. They have a different sign, which means the medicine is working because the temp is still dropping from the first derivative, but it's not working as quickly because of the second derivative. So there's a lot of ways to interpret the sentence. I'm going to use the same prompt as WebAssign just to make the homework as easy as possible, although it might not be the exact way that I would have interpreted it. But we would say first the time. So we're going to start by talking about how long it's been. So after 4 hours, the rates of, and here we want to put in what the first derivative is doing. Is the first derivative increasing or decreasing? Because remember, the first part represents the first derivative. So I would say the rate of decrease, because we're referring to the first derivative first. F prime was less than 0. The rate of decrease of the patient's temp is doing what? If we say it's decreasing, that means their signs match and it's speeding up. But if we say it's increasing, that means their signs don't match and it's slowing down. So which one's the truth? Well, let's look at the sign of the second derivative. The second derivative is positive and the signs don't match. So we don't want to say that it's decreasing and that means the signs match and everything's great. The temp is still speeding up so that it's getting lower and lower, faster and faster, which is not the truth right now. We have a positive second derivative. So after 4 hours, the rate of decrease of the patient's temp is increasing by, and I'm just going to round this to 0.03 degrees per hour each hour. They have opposite signs. It's decreasing from the first derivative, and then the second derivative is positive, so we'd say it's increasing, and for this one, that means it's getting less and less effective. So it's a little bit different from this example because it was dropping increasingly, but it was increasingly rapid, so that meant it was speeding up. It's just a lot to think about, and we're going to do another one with this, but I think that's definitely the hardest part of this section is talking about the second derivative interpretation, but we'll get the hang of it the more we do it.